Neanderthals also boasted slightly larger brains. It was about 1,400 cubic centimeters on average.
The Neanderthal, often imagined as a rugged and primitive figure, was much more than a simple step in human evolution. Known for their extraordinary physical strength and survival skills, they thrived in harsh prehistoric environments, often surpassing modern humans in certain abilities. Join us as we explore their unique features, starting with their brains. The brains of Neanderthals. Neanderthals, a distinct species within the Homo genus, had larger brains on average, about 1410 cm cube, compared to the 1350 cm cube average of modern humans. However, brain size alone does not determine intelligence. Cognitive abilities also depend on brain organization and how different regions are used. Neanderthals' larger visual cortices may have improved their ability to see in low-light conditions. However, they also meant that more of their brain was dedicated to sensory and motor functions, leaving less for higher-level cognitive tasks. Key differences also appear in the cerebellum, a part of the brain critical for motor control and advanced functions like attention and language. Neanderthals had smaller cerebellums compared to early Homo sapiens. This may have limited their ability to innovate and build complex social networks, which are crucial for surviving environmental challenges. Their elongated skulls, shaped like a football, contrast with the rounder, soccer ball-like skulls of modern humans. This shape difference reflects how their brains adapted. Neanderthals focused on physical coordination and visual processing, while modern humans developed more advanced, abstract thinking and social skills. While larger brains can suggest greater potential, they don't guarantee superior intelligence. Much of the Neanderthal brain was likely dedicated to basic bodily functions rather than higher-order thinking. In contrast, modern humans evolved brains better suited to language, art, and complex social structures, which helped us thrive as a species. Neanderthals' physical stature and strength. Turning to physical stature, Neanderthals were not as short as commonly believed. Male Neanderthals averaged 164 to 168 centimeters, about 5'4" to 5'6", while females were around 152 to 156 centimeters, about 5 to 5'1". While shorter than today's average European male height of 178 centimeter, they were comparable to earlier European populations. Interestingly, ancient footprints found in France suggest that some Neanderthals could reach 175 centimeter, similar to the average modern American male. Height alone, however, doesn't tell the full story. Neanderthals' weight and body mass index, BMI, give us more insight into their physical build. Estimates suggest male Neanderthals weighed 78-83 kilograms, about 172 to 183 pounds, and females 63 to 66 kilograms, around 139 to 146 pounds. This puts their BMI between 28 and 32 for males and 26 to 28 for females, a range considered overweight or obese by modern standards. But BMI doesn't account for muscle versus fat, and Neanderthals were highly muscular with a stocky build designed for strength and survival in cold climates. Their robust bodies were adaptations to their harsh environment. Shorter limbs and broader torsos reduced surface area relative to body volume, helping them conserve heat. Features like barrel-shaped rib cages and wider hips added to their strength and endurance, essential traits for hunting large game and navigating dense forests. In this context, their higher BMI reflects an evolutionary advantage rather than a health risk. Their build was similar to modern athletes like football players or weightlifters, whose BMIs often exceed 30 due to muscle mass rather than fat. Speaking of strength, Neanderthals were incredibly powerful. Research suggests they were at least twice as strong as the average modern human, particularly in their upper bodies. This strength was crucial for their close-range hunting strategies, which required powerful arm movements to thrust handheld weapons. In contrast, modern humans evolved for endurance and agility, excelling in long-distance running and throwing. For example, in tasks requiring brute force, a Neanderthal would outperform even the most physically trained modern humans, such as heavyweight boxers. Despite modern athletes' techniques and training, the Neanderthals' dense muscles and robust skeleton would give them a significant advantage in sheer physical power. Their anatomy reflects their role as powerful hunters and survivors in a tough prehistoric world. Neanderthals had a muscle system that gave them an advantage over modern humans. Their muscle fibers were denser and more efficient at producing force, an adaptation that helped them survive in cold environments where physical strength was key. On top of that, Neanderthals had about 20% larger lung capacity, which boosted their stamina during strenuous activities. While modern humans are lighter and more agile, we've evolved differently, prioritizing endurance over raw power. This means modern humans excel at activities like long-distance running or complex athletic moves like pitching in baseball. But in a direct physical contest, a Neanderthal's brute strength would likely prevail. Studies support this by showing that Neanderthal biceps were 16% larger than those of modern humans, and their forearm muscles could generate 126% more force. Neanderthals would have been particularly good at tasks like moving heavy objects or doing manual labor, similar to how construction workers rely on strength today. In popular culture, characters like the Hulk are often imagined with Neanderthal-like strength, symbolizing society's admiration for raw power. Neanderthals also had more type 2 muscle fibers, which are linked to explosive strength and quick movements. These fast twitch fibers allowed for short bursts of energy, ideal for sprinting or heavy lifting. Combined with their thicker bones and larger muscles, Neanderthals were well suited for strength-based tasks, essential for survival in their harsh environment. Their muscle mass relative to their body size was greater than modern humans, making them more suited for hunting large animals and enduring tough physical challenges. Their stocky build and shorter limbs helped them generate more power. On the other hand, modern humans have a more varied muscle composition, with a mix of type 1, slow twitch, and type 2, fast twitch fibers. This mix supports a wider range of activities, from endurance sports like long-distance running to strength-based exercises, reflecting the diverse pressures we've faced over time. Neanderthals' powerful jaws. In addition to their physical strength and robust build, Neanderthals also had a larger and stronger jaw than modern Homo sapiens. Their mandibles featured a pronounced chin and wider dental arches, which could hold larger teeth. This jaw structure was likely an adaptation to their diet, which consisted of tough, fibrous foods like raw meat and plants. Their larger front teeth, incisors and canines, were well suited for processing these tougher foods, as they provided more leverage for biting and chewing. Neanderthal teeth also displayed distinct features that set them apart from modern humans. For instance, their molars had a thicker enamel layer but were smaller overall compared to modern human teeth. This thicker enamel likely helped protect against wear from their abrasive diet. Moreover, studies suggest that Neanderthals had thinner cuspal enamel that formed more quickly than modern humans, indicating faster dental maturation. This could be linked to their shorter lifespans and harsher living conditions. In contrast, modern humans have smaller jaws and teeth, reflecting a shift in diet due to the invention of cooking and food processing. As cooking became more common, there was less need for large teeth, leading to a gradual reduction in jaw size over generations. The smaller anterior teeth in modern humans are better suited for a softer, more varied diet, unlike the robust teeth of Neanderthals that were adapted for tougher foods. Additionally, the shape of the dental arch in modern humans is more parabolic compared to the U-shaped arch seen in Neanderthals. This change is part of the trend towards smaller teeth and jaws as human diets evolved. Modern human teeth also have more complex cusp patterns and thinner enamel, reflecting different dietary needs and food textures. Neanderthals' hands. Neanderthals' hands were also chunkier than those of modern humans. Their hand bones were more robust, which initially led researchers to believe they had limited dexterity and relied mostly on a power grip, similar to how small children hold crayons. However, recent research has shown that Neanderthals were capable of using precision grips, which allowed them to perform delicate tasks such as tool making, painting, and crafting jewelry. Using 3D scanning, Katerina Harvati and her team studied the entheses, muscle attachment points on bones, of Neanderthals and early modern humans. Their findings revealed that Neanderthals often used precision grips in their daily activities, suggesting they had a level of manual dexterity comparable to that of modern humans. This challenges the outdated stereotype of Neanderthals as clumsy, instead showing them as skilled craftsmen capable of intricate hand movements. In contrast, modern humans have a more refined hand structure, supporting a wider range of grips. Human hands are generally longer and more suited for fine motor skills, with a highly developed opposable thumb, essential for tasks like writing or manipulating small objects. Modern humans use both precision grips, such as for writing, and power grips, like for lifting heavy objects, reflecting the diversity of manual activities we perform. Neanderthals, on the other hand, had hands that allowed for strength-based tasks while still being capable of intricate movements. Their thumbs were adapted for precision grips, even though they were less mobile than those of modern humans. This suggests that Neanderthals engaged in activities that required both strength and dexterity, such as tool-making and crafting. To understand these differences, consider the professions today. A painter, who relies on precision grips for detailed work, can be compared to Neanderthals engaging in activities like cave art or jewelry making. Meanwhile, a construction worker, who relies on power grips for lifting heavy materials, mirrors the strength-based tasks Neanderthals performed during hunting or tool making. The evolution of human hands is also similar to that seen in domestic animals. For example, dogs' paw dexterity varies by breed and purpose. Herding dogs have refined control for managing sheep, while larger breeds use stronger paws for pulling or carrying. Similarly, human hand evolution reflects adaptations to specific environmental challenges and lifestyles. Neanderthals' genetic makeup. On the genetic front, studies show that Neanderthal DNA is 99.7% identical to modern human DNA, highlighting a close evolutionary relationship. The first complete sequencing of the Neanderthal genome in 2010 revealed that while Neanderthals and modern humans share much of their DNA, significant differences exist, contributing to distinct physical and behavioral traits. For example, the DNA of up to 2% of non-African populations may be attributed directly to Neanderthals, indicating interbreeding when anatomically modern humans migrated out of Africa and encountered Neanderthals in Eurasia. This genetic exchange is linked to traits like immune responses and environmental adaptations. When comparing Neanderthal DNA to modern human DNA, researchers observe both similarities and differences. Both modern humans and Neanderthals share approximately 98.8% of their genome with chimpanzees, yet specific regions in the Neanderthal genome are more similar to the chimpanzee genome than to the modern human genome. This indicates that there may be some Neanderthal traits carried over from earlier hominins. Furthermore, specific Neanderthal alleles have been shown to influence traits like skin pigmentation, fat metabolism, and disease susceptibility. The genetic differences between Neanderthals and modern humans are not evenly spread across the genome. Some Neanderthal variants have been positively selected, likely due to their adaptive advantages in the specific environments Neanderthals faced, such as those related to skin and hair traits. However, other variants might have been disadvantageous and purged from the gene pool over time, showcasing the selective pressures that both lineages underwent as they adapted to their environments. One way to understand the impact of these genetic differences is through the concept of hybrid vigor, commonly seen in plant breeding. Hybrid plants in agriculture are typically more vigorous than their parental types as a result of greater genetic variance. In turn, the interbreeding between Neanderthals and modern humans might have provided adaptive traits genes to the human gene pool that helped early modern humans to adapt to new environments. Just as hybrid crops thrive better in certain conditions, some Neanderthal genes may have provided advantages, such as better immune responses or adaptations to cold climates. The ongoing influence of Neanderthal DNA on modern human health can also be compared to how inherited traits shape family health histories. For example, just as families pass down genetic susceptibility to conditions like diabetes or heart disease, modern humans carry inherited traits from Neanderthals that affect various aspects of health today. Studies have linked specific Neanderthal variants to an increased risk for conditions such as depression and nicotine addiction, illustrating how ancient genetics continue to shape modern human biology. Neanderthals' caloric needs. Neanderthals were complex beings with high energy demands, which can be compared to modern humans in terms of caloric needs. Estimates suggest that Neanderthal males required between 4,000 and 7,000 kilocalories per day, while females needed approximately 3,500 to 4,500 kilocalories. This higher caloric need is partly attributed to their larger body size and more physically demanding lifestyle. For context, male Neanderthals averaged around 77.6 kilograms, compared to the 68.5 kilograms average for modern humans. This larger body mass contributed to a higher basal metabolic rate, BMR, estimated to be 9% higher for males and 7% higher for females compared to modern humans. In contrast to Neanderthals, modern humans have lower caloric requirements. Typically, modern human males need 2,500 to 3,000 kilocalories per day, while females require about 1,800 to 2,400 kilocalories. This difference underscores the higher energetic demands of Neanderthals, likely driven by their larger body sizes and the need for greater energy to maintain body temperature in colder climates, an adaptation to their harsh environments. Neanderthals are often associated with a high-protein diet, primarily from large game. However, recent studies suggest that carbohydrates played a significant role in their diets as well. Evidence points to Neanderthals needing a balanced intake of macronutrients, potentially requiring 50 to 60% of their caloric intake from carbohydrates to sustain optimal health and energy. Given the large size of their brains, which needed considerable energy, a more balanced diet, including carbohydrates, may have been essential for maintaining cognitive and physical functions. This need for carbohydrates is in line with modern dietary guidelines, which recommend that about half of daily caloric intake should come from carbohydrates. The idea that Neanderthals thrived on a purely high-protein diet is being challenged by findings suggesting they likely adapted to include significant amounts of plant-based carbohydrates in their diet, further illustrating their dietary flexibility and adaptation to diverse environments. Neanderthals' speed. Neanderthals, often portrayed as brutish and slow, actually exhibited adaptations that suggest they were built more for speed than endurance. Their robust physique, with shorter limbs and a stockier build, seems to have been suited for sprinting rather than long-distance running. Modern sprinters, for example, tend to have shorter limbs relative to their body size, enabling greater power and acceleration in short bursts, which is similar to the Neanderthal build. This muscular structure and body proportions suggest that Neanderthals were adept at rapid, explosive movements, ideal for hunting in wooded environments where speed was key to ambushing prey. Genetic studies have shown that Neanderthals carried variants linked to power and sprinting abilities, supporting the idea that they were adapted for quick, powerful movements. This genetic predisposition likely made them effective hunters in their specific ecological niche. In contrast, modern humans are adapted for endurance running, a trait involving a more elongated body shape, longer legs, and a narrower pelvis. These adaptations enable efficient locomotion over long distances, which was essential for persistence hunting, a strategy where humans would chase prey over extended distances until the animals were exhausted. This method of hunting was particularly effective in open grasslands and varied terrains, where stamina played a crucial role in securing food. Neanderthals' lung capacity. One of the most striking features of Neanderthal physiology is their lung capacity, estimated to be 20% larger than that of modern humans. This difference in lung capacity is closely tied to their unique thoracic structure, which had significant implications for respiratory efficiency and overall energy needs. Recent studies have revealed that Neanderthals had a distinct ribcage shape that supported a more efficient breathing mechanism. Their ribcages were not necessarily larger in volume, but were shaped differently. The Neanderthal thorax was wider at the bottom, which allowed for a larger diaphragm, an essential feature for deep, efficient breathing. This anatomical trait enabled them to take in more air with each breath, supporting their larger body mass and higher caloric needs due to their stockier build. The diaphragm's role in respiration was likely more dominant in Neanderthals than in modern humans. While modern humans rely on both diaphragm contraction and ribcage expansion for breathing, Neanderthals' breathing mechanics were adapted to maximize inhalation using their larger diaphragm. This adaptation would have been particularly beneficial for Neanderthals, who engaged in physically demanding activities such as hunting and gathering in harsh climates, which required high energy output. In contrast, modern humans tend to have a more elongated thoracic structure that supports a greater range of motion, which is beneficial for activities like endurance running, but may not match the efficiency of Neanderthals' lung capacity and breathing mechanism for high-intensity physical exertion. These differences in lung capacity and thoracic structure reflect broader evolutionary adaptations, Modern humans have evolved lighter, more agile skeletal structures suited for endurance and long-distance activities, while Neanderthals' robust builds were advantageous for short bursts of strength and power, traits essential for their survival in physically demanding and cold environments. To put this in context, imagine comparing the physiology of Neanderthals and modern humans to automobiles. One vehicle, representing the Neanderthal, is built like a truck, with a powerful engine designed for heavy lifting and rough conditions, while the other, representing modern humans, is a sports car optimized for speed and agility on smooth roads. Both excel in their respective environments, but are not directly interchangeable. Similarly, the energy demands of Neanderthals were greater due to their physicality. They needed more oxygen to fuel their muscular bodies, and their larger lung capacity and efficient respiratory mechanics allowed them to gobble air more effectively than modern humans. Neanderthals' resilience against severe injuries. Neanderthals also exhibited remarkable resilience and adaptability in the face of severe injuries. Living in a world filled with large predators and the physical dangers of hunting, Neanderthals were prone to traumatic injuries. Evidence suggests that between 79% and 94% of Neanderthals experienced at least one traumatic injury during their lives, including crushed limbs, fractured skulls, and broken ribs, often resulting from hunting accidents or encounters with dangerous animals. What is especially remarkable is that many Neanderthals survived these injuries for extended periods, sometimes months or even years. This indicates that they received care from their community. Dr. Penny Spikins, an archaeologist at the University of York, points out that the survival of injured individuals implies a well-developed system of care among Neanderthals, likely involving collaboration and significant knowledge about treating wounds and managing pain. For example, skeletal remains show signs of healed fractures without severe deformities, suggesting that Neanderthals may have used primitive splinting techniques to stabilize injuries. Neanderthals may have also turned to natural remedies to aid recovery. Traces of poplar, a plant containing salicylic acid, found in their dental calculus suggest they might have used it as a painkiller, indicating a level of understanding about the medicinal properties of plants similar to traditional healing practices in contemporary human cultures. In contrast, modern humans benefit from advanced medical technologies and healthcare systems that address a wide range of injuries. While modern humans also experience injuries from accidents or sports-related incidents, the recovery process is often supported by access to hospitals, surgical interventions, and rehabilitation programs. For example, broken bones are usually treated with casts or surgical pins to ensure proper healing and alignment. Despite the technological differences, the essence of care, whether in prehistoric or modern contexts, remains similar. Community support is crucial for recovery. Just as Neanderthals relied on their kin for assistance after injuries, modern humans often depend on family and friends during recovery periods. The emotional and physical support provided by close social networks can significantly influence healing outcomes. Neanderthals' hunting techniques. Neanderthals, our closest extinct relatives, were highly skilled hunters and gatherers whose dietary practices and hunting strategies provided valuable insights into their lifestyles and adaptations. They primarily relied on a meat-based diet, hunting large and medium-sized mammals such as red deer, horses, bison, and even woolly rhinoceroses. Archaeological findings show that Neanderthals targeted prime-aged adults rather than juveniles or older animals, which reflects a strategic approach to hunting that maximized their nutritional intake. The isotopic analysis of Neanderthal remains further supports their high reliance on animal protein, reinforcing that they were active hunters rather than mere scavengers. While Neanderthals are often depicted as big game hunters, recent studies have revealed a more varied diet than previously thought. Evidence from various archaeological sites suggests they also consumed smaller game, birds, fish, and even plant materials. For example, at the Paya site in France, Neanderthals exploited starchy plants alongside their typical large herbivore diet, indicating a more adaptable and varied subsistence strategy. This adaptability in diet mirrors modern human foraging practices, where diverse food sources are utilized based on availability and seasonality. Neanderthal hunting strategies were sophisticated and involved cooperation. They often hunted in groups to take down large prey, employing tactics such as ambushing animals in natural traps like ditches or depressions. Evidence suggests Neanderthals used stone-tipped spears for thrusting, a method that was effective in close-quarter encounters with large games. This tactic required significant teamwork, as hunting a large animal like a straight-tusked elephant would necessitate the coordinated efforts of multiple individuals over several days. The archaeological record also indicates that Neanderthals were not confined to localized hunting grounds, but instead moved strategically across landscapes to track the migratory patterns of prey. Studies show that they established seasonal hunting camps near reliable food sources, suggesting an organized approach to their subsistence activities. This seasonal mobility contrasts with the more sedentary lifestyles often associated with modern humans in certain historical periods. In contrast, modern humans exhibit a different approach to hunting and gathering that has evolved significantly over time. While early modern humans also hunted large game, they developed more advanced tools, such as bows and arrows and atlatls, spear throwers, allowing for more efficient long-distance killing compared to Neanderthal methods. Additionally, modern humans adopted a more omnivorous diet that included cultivated plants and domesticated animals, a shift facilitated by the agricultural developments that began around 10,000 years ago. The differences in hunting strategies can be illustrated through familiar examples. Contemporary hunters often use technology like rifles alongside knowledge of animal behavior to maximize their success. Similarly, modern foragers rely on a combination of hunting and gathering techniques to ensure food security throughout the year. In contrast, Neanderthals relied heavily on their physical strength and cooperative strategies, without the benefit of advanced technology. Furthermore, the diverse diets of both Neanderthals and modern hunter-gatherers can be compared to contemporary culinary practices, where local ingredients are prioritized based on seasonal availability. Just as modern chefs adapt their recipes according to what is fresh and accessible, Neanderthals likely adjusted their diets depending on the animals they could hunt or the plants they could gather at different times of the year. Thank you for watching the video to the end. If you liked it, please consider liking and subscribing to the channel to enjoy more similar content. We'd love to hear your thoughts about the super strength and other mind-blowing characteristics that Neanderthals possess in the comments. Until next time!